For our final presentation, we're going to watch a pre-recorded video by Bhumika talking about MARRS, a framework for multi-objective Riskaware route recommendations using multitask transformers.
Hello everyone, I am Bhumika, one of the co-authors, presenting our work titled as MARRS, a framework for multi-objective risk-aware route recommendation using multitask transformer. I am starting with the need of a risk-aware route recommendation. Currently, route recommendation systems do not consider risk as a factor for navigation recommendation. For example, providing routes which are accident or crime free. These type of recommendations are helpful for tourists and general public. As we can see in the figure, there is a scenario of risk-aware route recommendation where origin and destination are given and route segments provide the risk level of road, and our system will provide more safer route which is highlighted in the green color. Before moving further, I would like to provide some limitations of existing risk-aware route recommendation systems. First one is most of the systems are taking care of single objective only, like only weather, crime or accident, whereas in our case we are considering multiple objective at a time. In some literatures, we have found that there are multi-objective route recommendation also available, but their analysis is only coarse-grained and level. Whereas in our case, we are providing on the routes on the behalf of particular road segment. Next is some of the recommendation systems are considering these objectives one after another, whereas in case of a real-time setting it is not possible. So we are taking this multiple objective parallelly or at a time. Last research gap that we have observed is user may provide higher weight to some factors like for crime higher weight than road accident, which may result in an unbalanced route, like which is taking more time and having low risk. That is what not the user want. So our system will provide the optimal route from source to destination. Our contributions are as follows. First one is we propose a novel, wide, deep and multitask learning framework that collectively predict road accident, crime risk and traffic flow. These are the multi-objectives for all road segments using heterogeneous open data. We then extract temporal, spatial, external and reference features that are utilized by transformer-based multitask learning configuration to predict the risk on roads. Next, we formulate the optimal risk-aware route recommendation problem as minimizing multi-objective using adaptive epsilon constraint, and our finding shows that the framework provides better results than baseline methods in determining the risk of road segments. So there are several challenges that we have faced while solving this problem. So first one is heterogeneous data sources. As we are considering multiple sources for increasing the prediction accuracy, so their data distribution also varies. So we need to take care of that. Next challenge is the sparsity of data. Like these events, accident and crime do not happen very quickly. So we have very few samples per day. And next problem is complex spatio-temporal relation. So we need to capture spatial, temporal and contextual relationship of data so that the prediction accuracy can be increased. And the last challenge that we faced is the multi-objective optimization, because we need to provide a balance between different objectives. So we come up with 5-layer framework to tackle all the challenges and issues. So first layer is the dataset layer, which comprised all the common dataset and specific datasets, as we can see in the figure. And next is the feature extraction layer, where we consider spatial, temporal, external and reference features. Next layer is the deep learning layer where we consider the transformer model. Fourth layer is the Riskaware recommendation, which comprised of adaptive epsilon constraint technique. And at last, the quality analysis layer, which comprised of model comparison, effect of features, and model structure. The figure depicts the architecture for predicting risk at various road segments. So at first we consider different features such as temporal, spatial, external and reference features, and in the next block we are considering embedding layer, which comprised of categorical features and continuous features, and these embeddings are passed to the deep network. So this deep network is a shared network between different tasks, and it comprised of transformer model that is used to extract spatial and temporal information. Next we consider the wide network or the wide component that is used to provide the correlation among task specific features. At last, there is a tower network for different tasks like crime, accident, and traffic flow. These are different data sets that we have considered for our experiment, which is from the New York City, and this figure shows the accident, crime, and POI distribution in the New York City. We also consider different contextual data sets for increasing the accuracy of predictions like anomaly data, vehicle speed data, NYC road data, NYC meteorological data, and NYC calendar data. Our first experiment on the dataset is how well does our framework predict risk when compared to baseline techniques. As we can observe in the table, our framework is providing better in terms of mean absolute error, mean relative error, and RMSE. So it may be due to the advantage of spatial temporal transformer, or we are considering deep and wide block in our architecture, so there might be the increase in terms of performance measures. And we can also observe from the table that neural network perform better than the traditional machine learning methods like support vector regression and linear regression. And we can also infer that LSTM and GRU do not consider spatial context, therefore their performance is less than our proposed framework. And STRNN also do not consider the spatial information, whereas in our framework we are considering various spatial, temporal recurrence and external information, and therefore there may be an increase of the accuracy. Our next set of experiment is to observe the effect of different component combinations on performance in a joint architecture. So in the figure, ST denotes spatial block, TT denotes temporal block, and WB denotes the white block, and DB denotes the deep block. We do the ablation study, that is, we are removing each block one after another and observe the performance measures. And from the figure we observe that deep block have a significant effect on the performance matrices. And last experiment that we have performed is how does our framework overall performance changes as a result of contextual information. So we are considering various contexts like POI, anomaly data, meteorological data, and calendar data. So we observe that POI data have the significant effect among all different contexts, and predicting risks with higher accuracy require POI, anomaly data, meteorological and calendar data in addition to time series data, that is the base data sets. So this contextual information have an important effect on the overall accuracy. So the main takeaways from this presentation are we have used a large scale heterogeneous urban data and investigated the challenge of risk inference at the road level in this research. Next, we have considered the spatial, temporal, external and recurrence features that are fed into a wide deep multitask learning model for predicting crime, accident, and traffic risks. And we structure the problem as multi-objective optimization problem, and we identify a small range of non-dominated paths with varying safety trade-offs. Thank you for listening. You can contact me for more information at my mail ID bhumika.1@iitj.ac.in, and you can follow our lab work by scanning the QR code or may visit our website vanet-iitj.github.io. Thank you once again.
Excellent. Unfortunately, because that's a recording, we don't actually have the ability to take questions now. But if you want to leave any questions on the RecSys Hub, I'm sure the authors can get back to you on that. Yeah, that's our session. Thanks for attending, everyone. I think we have a lunch break now, and the next thing up will be in this room at 2. It's going to be on large-scale recommender systems. So thanks, everyone.